Hey everybody, this is Larry. This is day 13 of the Leetcode Day Challenge. Happy, I was almost going to say happy birthday. What is wrong with it? Hope everyone's having a great weekend though, or beginning one. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I just did a very easy 7 mile run after doing strength training and man, it was a tough day's strength training. Because I'm right now I'm just doing maintenance, meaning I'm not doing anything. I'm not building strength. I'm just trying to maintain the strength that I have. And I was doing squats, and I was doing 100. Just doing 100 kilograms. I usually do 3 sets of 10 of 100 kilogram squats. But today I was just not really able to finish because yesterday I jogged like 13 miles or something like this, and my groin area is just a little bit tight, so I just didn't feel comfortable going super heavy. So, but I still did 7 miles afterwards. So hopefully today I will sleep kind of well, even though I have to wake up early. But that's another story. But tomorrow afternoon I'll sleep well. But anyway, let's take a look at this problem 2751. The reason why I checked was because it felt like it was recent, but I guess we'll see. but apparently even that's been like a year ago. So hit the like button, hit the subscribe button, join all the buttons. And today we have robot collisions. There are n one-index robots, each having a position on a line, health, and a movement direction. Okay. Okay, fine. You're given a zero indexed integer array's position, health, and a string of direction. Okay, all integers in positions are unique. Okay, so they don't start the same place. They all simultaneously same speed in a given direction. If they share the same position while moving, they will collide. If they collide, the lower health one is removed, and then health of the other one is decreased by 1. The surviving robot contains in it. Okay. Yeah, I mean, I think this seems like a. I couldn't help but notice that I got 2 wrong answers on the other one, but maybe it's just for something silly. But I feel like the idea is pretty reasonable for me to kind of illustrate it. So I'm actually just, give me a second, pulling up the drawing board so that you can see me draw. But sorry, I'm looking for my drawing pen. So that's why I'm always looking for it. But yeah, for this particular problem, it seems like, okay, so let's say you have the number line or whatever, and then you have some robots, here, say here, and they either go left or right. So maybe let's say this goes right, this goes left, this goes it's at the same speed, right? So that means that if they go in the same direction, they'll never meet, right? But if they go in the opposite direction, then this and this one will meet, right? Here, and here, right? And of course, this is with respect to, this is on the x-axis, this is on the t-axis, which is for time. So as time happens, then you have these points. So the idea that you can have is just simulation, right? And then just remove them one by one. In theory, so okay, so I think that's basically the idea. You just remove them one by one. In theory, what I wanted to say is that I'm just looking at the constraints right now. N is 10 to the 5th, which is reasonable, or like within what I expected. The thing is that if you drew that complete all the collision points, like if you drew all the collision points, then it's going to be n squared, because in the worst case, you have half of them facing left, half of them facing right, and they all collide with each other. So you have n squared intersections. And then even if you do anything funky, or even if you don't do anything else, that's too slow, right? So in that sense, after this, visualization becomes an implementation problem. And what I mean by that is just that we are now trying to figure out how to get the complexity down, right? And my immediate idea is just, so we have someone like this, I'm bringing back for a sec, is that we just, so one thing you can realize from this problem is that every time there's a collision, we have one fewer robot, right? That means that at most, we should only handle O of n collisions, right? So that means that if we are able to sort it in this way, it'll be n log n, and that'll be fast enough, kind of, maybe. I mean, I'm doing a little bit hand wavy here because I'm still trying to figure out how to put all the pieces together. But the idea is that, okay, if this kind of fits logically, we should be able to get something down to n log n, and n log n should be more than fast enough, usually. I mean, Leetcode is silly, so I don't know, right? And then my first idea is, maybe, I don't know if this is an obvious one, it's just an idea, right? I keep on bringing this. It's just that for each dot, we only care about, or we don't have to construct all the collisions ahead of time. We can just construct one at a time, right? Meaning we can construct this one for this dot. We could just care about this one, because everything past that, we'll worry about it later, right? Because this guy may not even survive. So why do we worry about it? And the same for here. We don't have to worry about it until later. So then now it becomes, okay, given this dot, what is the first collision? Well, the first collision is just the first one that is to the right of it, right? That is going left. Because if it's going right, then this would never meet. So we just want to do it that way. So I think that's basically the idea, and we can construct something like this with a heap for handling like the order of stuff as we kind of update over time. So I think that is sufficient enough for us to start implementing. So let's do it. Yeah, I think the ideas are pretty okay. Let me know in the comments if so far the ideas are not whatever. But yeah, so we have. So what we want is, so let's just say we zip them together just because it's a little bit easier to handle. PhD, PhD, huh? But yeah, so for now, I'll just keep it simple. I mean, maybe we're doing more work than we need to, but we'll keep track of the things that are facing. Well, this is heading to the left and heading to the right, right? Okay, so then now this becomes easy to kind of write, right? So direction is equal to L, then well, left dot append, let's just say P and H, right? You could also write this differently, but that's fine, right? So then now we have left and right, and as we said, now we want to care about the collisions, right? So I mean, I think that's, yeah, and keeping in mind that because we're going from left to right, and P is sorted, I am incorrect. P is not sorted. It's just distinct. Okay, well, I mean, that's fine. Then now then now we just sort both of them. Not a big deal. But for some reason, I thought they'll be sorted, but it doesn't really matter anyway, because now we're going to do some binary search, right? So then now, how do we want to think about it, right? I mean, so for P, H, and left, right, we want to binary search, so, or maybe right. Maybe that makes more sense, actually, for me. My visualization, it doesn't really matter, because then now it's on the left side facing right, right? So then now, yeah, we want to binary search the robots facing left, the next one, right? So that means that we want to do something like bisect dot bisect. Am I spelling that wrong? No, that's right. Bisect left, bisect left, bisect right. It doesn't really matter in this particular one because all the positions should be distincted. Distincted? That's not a word. Distinct anyway. Position, and then we want to search on the left side by the P, right? So this is going to be the index, and then the right sub-index, it's going to give us the P2, H2 maybe. But we don't really have to. Do we want to care about it? I'm just trying to think for the data structures that we can use, because the idea that I have right now, right, is that okay, now we construct the events list of the next collusion. So now we have a event list. We can construct that just by just some math formula that we'll go over in a sec. But then now we want to talk about updates and remove those and stuff like that. And in that case, is the data structure that we have right now still the best for it? And I don't know. Because we want to be able to move, right? So let's do that. Yeah, I think what I want to do is just change this to a sorted list. So then, because the reason why I want to change this to a sorted list is because, well, I mean, one is that we sort this anyway. So, it doesn't save us any time to have a list. I mean, save us some constant time, but not in complexity. But then also, because we want to be able to remove, and that's the critical thing in why I wanted this to be a sorted list from sorted containers. In other languages, you can imagine using like even just like a set or something like this. It should be fine, because you're able to get removal in a good, and you're able to binary search. So you just want a data structure that have binary search, and add and removal. That's basically the abstract data type that you're looking for, and in Python it is a sorted list, in reasonable time, of course. I mean, yeah, maybe, but yeah. And then here, then now we try to figure out time of collusion, right? Oh, and this is now, this is even just wrong. This is left of index. Huh, that's terrible, Larry. But in any case, this is gonna be left dot bisect left of p, but that's not even quite right, because now we're searching a p versus whatever. But it doesn't really matter, because like I said, it's unique, so it should get the next one anyway. Okay, so time of collusion, right? So basically, because they all move at constant time, you could just say that they move for the purpose of, it doesn't matter, 1 unit every second, say. Then now you could figure out what time they collide, right? And of course, the distance is going to be, say the distance is equal to, technically, this is facing left, and this is going to bisect right, so it's strictly going to be P2 minus P, right? Maybe I'll just do P left, P right, and P left is because it's on the left side, right? So left side facing right. And so we have this, right? And of course, then now the time is just going to be distance over 2. But we don't even have to, I mean, we could do over 2. It doesn't really change things that much. But then now we're like, okay, well, if we're going to divide everything by 2, then we might as well just say the speed is half. So then now distance is the time that it takes to collide, right? Sounds reasonable. So then now, maybe I want an index. Maybe that's what I'm missing here. It's a little bit. No, what I want is the index of left and right. Right. How do I want to store this? I mean, I guess we can just be it doesn't really matter. We could keep the index. We can just store all the parameters that we have, which is that, okay, so then let's say we have a defense, and defense is going to be a heap, but we can just kick it off with, so defense, we want to append the distance, which is technically the time of the collusion, right? Then now we have PL, HL, PR, HR, right? And that should be good enough. Yeah. Yeah, I mean, I should be okay. I was thinking that also we want, I mean, because we don't have to, for symmetry reasons, we don't have to do the left side, because the stuff facing left, the closest is going to be one of the rights, even though some of them can have duplicate matching partners. only one of them will matter anyway, right? At least for initially. So then now here, then now we want to do a what's it called? Heapify. We want to heapify the events, right? So then, well, yeah. What are we trying to figure out again? Oh, the health of the oh. So we do actually care. I forgot to read the rest of the part, but we do care about the index. So okay, so let's just put in the index then. So we're gonna do enumerate. I mean, we just need it, right? Like, there's nothing we can do about it. So then here, that's a little bit confusing, but doesn't really matter. Again, right? Okay, so then now we have index of left, index of right, and then here we can be a little bit lazy then. Can we? Not really, actually. Yeah, let's just do it this way. I mean, you can kind of with a sort, but okay, fine. And then we heapify it, right? And then maybe just while length of events is greater than 0, right? And we have an answer is equal to what if robot's destroyed? Then what happens? Oh, it's kind of awkward, but okay, fine. So we don't have to do this live, I suppose. Because when we remove robots, they die anyway. So okay. So okay. Yeah. So then now we handle the events, and on the events we have heap pop. We have all this thing. The time we don't really care about, honestly. Yeah, because all the positions are unique. Only 2 things can happen on one time, or like with one particular robot, it can only collide with one other robot. So there's no whatever. Right, is equal to this, and then now we just check the health, right? So if HL is equal to HR, then they both die. So then now we want to remove them from left and right, right? So left dot remove PR, HR, IR. Remember that is the right side facing left. Maybe it is confusing. I don't know. Oh. Yeah, right. You can also write this a little bit cleaner and by taking over considering the overlapping states, but I don't want to mess with it. So yeah. So okay. So if left is greater than R, then we remove the right one, which is on the left side, right? And then, but the left one, we also remove it to do the health -1 thing, right? Can you get negative health on this? I guess if you're both at 1, there's no way to get 0 and still win, right? So okay, so maybe that's fine. Yeah, and then subtract 1, and then write that remove. Oh, sorry, write that add. Then we add it back in, right? And then what we want to do is well, we add this back in, but then now we want to care about what is the next robot the right will run into, and this is on the right side facing left. So then now we have index is equal to left dot bisect left of PL is actually fine, which is kind of awkward. You don't have to update it with distance because you already eliminated the other robot. Yeah, but there are some stuff I have to check. So I think this one is kind of easy to mess up for sure. Yeah, and then hip q dot hip push events. So then we have new distance. Let's go to still PR minus PL. No. Well, I mean yes, but I have to update. Wait, what? Oh no, this is right. But yeah, okay. So then now we have to update this. If index is greater than, or if left length, if there are robots left on left. I guess I have to check that in every place, don't I? Which is kind of very awkward, but okay, fine. Yeah, okay, fine. Maybe I could just do it here, actually. Okay, so then now we push the events back of the distance. Again, just facing left, facing right, and we're kind of Gucci. But yeah, now we have to do it for the other side. But before that, we actually have to check that this is still alive, right? So I mean, we could do a bisect, but I think there's like an exist thing. I don't use sorted list enough. Python exists. Like we could just check, but I'm just looking at the API. Discard, no. Update, no. Count? I guess count maybe, right? Contains? I guess so, okay. So if one of them doesn't exist, we have to just continue, I think, because that means that it already collided. Okay, so we can do something like this. So this is not true, or not in left, then we just continue because one of the robots are. Okay, so then now we handle the left side, right? And only if there are robots left, we do it. Otherwise, then we just do it to the other side, so symmetry things. Maybe there's an update, I don't know. But yeah, and then now we have to binary search for the other one. Assuming that it exists. This is a typo. I guess this is actually the same, so that's fine. Okay. And then now, after everything is done, yeah, then only one of the lists will contain values, but I think it doesn't really matter, so okay, fine. Right. You have to sort it twice. I think that's that's a little bit annoying because you have to sort it by the original index, and then or you could find it with stuff, but I don't know. It should be fine, right? PhD and I guess we don't use D. No. It's the index actually. We don't use D at all, but in left. Well, I guess we don't use precision. We don't care about precision. We only care about the health and the index. So then enter that append, index health. Same thing. And then now we can sort it. and now we can just return x4 x. We skip the index, right? Something like this. All right. Let's see if we're. Oh man. The length of. Oh, this could have no items. I guess that's true. Huh. Or like it's the next item could be off the map. That's good. Okay, it's a good thing that we caught it. Yeah, we caught it. Actually was thinking about this, but then I think I just got distracted and forgot. Or I thought about it here, really. But then I just was like, wait, it should be good. But then I was wrong. It was not. Okay. Got the Q1 right, Q2 not so good, Q3 also not so good. Oh, did we not? Huh, wait. Okay, let's look at this one. This looks easy to handle. So 11, okay, that's Gucci. Let's print the events. The events looks like am I handling this weird? Maybe I am handling this weird. The events at time 1 maybe I am doing a little bit weird. Maybe well, I mean, the thing that I was banking on is that there's some symmetry here, but maybe not. Basically, because basically this is saying that all the things facing right. So robot 1 and robot at 5. The 1 matches the one at 2, and the 5 should matches the one at 6. But that's not what's happening, is it? Why is this not match up with? This is match up to the wrong robot, maybe. 5, 11, 2. Yeah, why is? One 10 0. What is this? Oh, 0 is index 1 and 10. Why is that match up with 6? That is actually weird. Did I have a typo somewhere? Alright, let's just look at. I mean, that's the thing with writing so much code, is that it's just very easy to typo. So left is 2, 10, 1. What is the 2 again? Precision? Yeah, that sounds right. Oh, this what is this P? From? This is PL. Okay. Like I said, easy to typo. Where am I? How did that happen? I think that is the one thing that bites me a lot in Python, is that like these shadowing variables from this P, like it kind of carried it through and somehow not complain enough for me to like notice easily. Wait, does it work now? Nope. Alright, well, it works for this case at least. Finally fix that. This one, you have this, the 3 and the 5, kabam. And then 15 and the 12, right? Yeah, this should collide. Oh, huh. I see. So basically, the way, because of the asymmetry, well, I guess it doesn't even matter in this particular problem. But I mean, I know how to fix this, but I just want to explain it. So my bug is that the robot at 3 matches the robot at 5. The robot at 2 also matches the robot at 5. And then when we destroy both 3 and 5, or the middle 2 robots, and then during this loop we skipped it. But instead, what we should do is queue up the next thing here. I mean, I guess so. Because that, well, I mean, so the way that I'm thinking it through is just making sure that we don't go back in time by accident with some stuff. But I think because on this collision, that means that the robot that is missing, we want to go the other way, so it should be good. Okay, so that means that we want to say something. How do we write this in a better way? Can both robots be dead? I guess so, but what is the cleanest? I'm just trying to think about the cleanest way to write this. Okay, so maybe so I want to also like make it slightly efficient, but not enough. Well, this is missing, I think, or destroyed, whatever. I just say missing. Then we can just continue. I mean, I think you could write this in a cleaner way, but I want to just make sure. Left missing, that means that right is not missing. Then we want to go on to find the next robot for right. Maybe this should have been thing. I don't know. Like maybe this should be a helper function. This is why I have two wrong answers on the other one, because it's just so easy to get wrong. Okay, but okay. So if left is facing left is missing, then we want to find something that is facing left on the right side. So we want something like this. Yeah. I mean, I think this we continue anyway, because yeah, and then the same idea with the other one. Yeah, but maybe this should have been a helper. This is kind of nasty. Okay, let's give a YOLO submit. Am I confident? Let's just say I'm 60%, say. More lazy than whatever. How did this happen? This index, yeah, what am I doing? What? Oh, give me this one. Why is this giving me issues? Let's see. So 3 and 47, and this is the health. 3 looking left and 47 looking right. So this is. Oh, do I not have a thingy here? Okay, yeah. I mean, we put it in here. I thought I forgot about it. It's just lousy. Yeah. Okay, fine. Right. Oh no, this isn't that. This is the. I'm just being. I'm not even thinking right now, clearly, and that's been kind of a little bit sloppy. Come on, one fewer wrong answers. No, I timed my other. Like conceptually, this one should not be that bad, but it is clearly a little bit messy. So facing left is this one, and then you have these two things to the right of it, facing right. How did they collide? I mean, my code thinks that it just crushes everybody, like this one, but 238 is to the other side, right? So why is this? So okay, so it looks at all the things facing left. So it looks at this one, and then it collides correctly. It should be, and yeah, it collides correctly. Wait, no. It should be colliding with this one. Whoops. So it collides correctly. Oh, I am just being dumb. Yeah, I mean, I just copy and paste. But yeah, I actually was thinking about this. I'm just like, I think I don't know why I have such, like, I'm just kind of disappointed a little bit. Not because I mean, well, also because I got it wrong. But like, it's not like I didn't think about it. It's just that I forgotten about it after thinking about it. But the short answer is that for bisect left, this makes sense when you're on the right looking for something on the maybe the other way. How did I have? Because I was thinking about for this one, you have stuff facing right. Wait, no, this is wrong too. Why? What? Is that true? And how did I get this one wrong? But I was thinking about it. Maybe I got the wrong one because it's just so easy to think. Oh no! This is facing right, so we want the next one facing left. So this is right. But this one I think I just got. Well, this one too we have to fix. But this one I just got lazy, to be honest, because I was just like like I had in my head that I was like, Larry, remember that on the other side it's not symmetric, but I just forgot about it. And the short thing is that this it's because you're on the you're looking left. You want something facing right. Am I just like, I don't know anymore. This is so confusing. Oh no, this is right. But yeah. But basically you have this position, but it should be the one that is, because the idea of bisect left is that it gives you the next number. So and on the things, it's just so confusing to say and visualize in my head. When the stuff facing left, it makes sense that this is the next one, but this should be the previous one. So in this case, it should be this minus 1, and here as well. Unless I got them confused, and it's the other way. But this one should suss it out for us. Yeah, what a silly mistake. I mean, that's the problem. Oh no, I'm gonna get okay. So I mean, I guess I matched my contest record, but. Like, I think the idea is okay, but I don't know. I'm not happy about this. Or I'm not happy with the two silly mistakes. I've been doing a lot of these kind of silly mistakes during the contest. Like this one, like I was thinking about. I mean, I thought I did fix it even here, but I just didn't carry it over here. So I don't know. And then this one, I was thinking about it as I was as I was finishing this, but I forgot that the other. Like by the time I think some part of it is because I was talking out loud, and I also jumped back and forth a little bit. It wasn't here. The reason, well, this one's wrong because I copied it from here. But I think when I did this, and then halfway through, like, and I just thought that this would be the same, so I didn't really think about it because I forgotten about it here. Because after I did this, I jumped to doing something else. I forgot what it is. I don't think it was this. But even though I did miss this case as well, which is actually pretty not great. But it was an example. But yeah, after doing this, I think I jumped to doing something else, and I came back and I just copy and paste, and I forgot that we want to binary search on the other side of the coast is. So I don't know. I mean, I'm just not happy about it because it's just very silly mistakes. And it's not even unforeseeable. Like I literally thought about it. I mean, I don't remember if I talked about it out loud. I don't think so for this one. But I remember like I was like, Larry, remember to do this. And then as soon as I saw it, I'm like, oh yeah, I forgot. just getting old. Just forget. I need to take more notes as I'm writing. Maybe I just need like to remember how to do it. Yeah, oh. Yeah, I mean the way that I did this was with a lot of heap and a lot of same idea really. Yeah. Yeah, and I did index -1. I'm curious why I don't know. I made the same. I don't know anymore. But yeah, I did come to about the same solution though. So with the health things, hmm. I don't know. But yeah, so let's go over the complexity really quickly. I'm just sorry, friends. I'm just a little bit disappointed in myself, obviously, as I said. But yeah, and this took 40 minutes, which I mean, I guess I was explaining it partly, but that's still kind of slow. Considering I knew what to do basically immediately, it was kind of slow. But yeah, this is sorted list. This is n log n just from adding it to sorted list. This is n log n because this is for each item. You do a binary search, right? This is n log n. So yeah, the number of events is reset. So this part maybe is the hardest to prove a little bit, but maybe not that much, right? Because like I said, every collusion, that means that for every event, we lose one robot. So at most, there'll be n events, and each event will take all of log n time with some number of adds and removals to heaps and the sorted list, but like a constant number of them, right? So it's all gonna be just log n. So this is gonna be n log n in total. And remember that the number of events in the beginning will only have all of n events because of this thing, right? Because we only do it from one side, and so it's just going to be all of n number of events. So it's just going to be capped by n log n, and both of these other these should be linear, but there's the last sort here. So yeah, that's all I have for this one. Let me know what you think. Let's show you the top, the events part. Even though that's still too big. So the big if statement, but it's mostly symmetric, but it could be a little bit not. And yeah, and then the end. That's all I have for this one. Let me know what you think. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this explanation and all this stuff. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.